Alright, let's turn next to the second problem, which is also the last one we will do. And here we have a buffet and the following eating preferences from people of different geographic origins was observed. So imagine there's a hotel and they have visitors from the north, the east, the south, the west. And the buffet, they offer beef, pork, chicken, fish, or vegetarian. And we can see the numbers of people from each region and how often they grab the plate with either beef, pork, chicken, fish, or vegetarian. Okay, so this time I really want to do everything very comprehensively and also draw the exact chi-square distribution, and let's calculate the critical chi, the test chi, and let's also draw that nicely. Okay, so here we have our actual observations. Then I copy that underneath and I delete all the values in the gray cell because in that second table I need to put the expected, and then I copy down that cross tab a third time, again leaving space below, and here I calculate the chi-squared statistic. So chi right, I just write chi raised to the 2, and we don't really need the sum. We don't really need the row totals and column totals. Okay, so it's maybe okay, so now that looks nice. And the first thing we do is we create again the expected values. And for this I use again the formula where I just know that the expected for beef is the beef column times, for the north people, the row total divided by the total of 100. But again, I need to make sure again that as I copy the cell for B7, if I copy that down, I don't want the row to move. And for the column G3, where I have the row total currently for north, when I copy this down, I mean, if I copy that to the right, I don't want the column to move to the right, but I keep the 3, the row, because I copy down the rows. And for G7, where we have the total, I highlight, or I fix both with the dollar sign. Okay, so now for the first cell, if we assume that origin and beef consumption are independent, then for the north and beef, we would expect the value of 6. Okay, so now that I have the formula, I can just copy the formula to the right, and then I can copy it down. And maybe I'll make that bold, and I don't know if you can really see well the background. Let's make that a little bit lighter. Okay, so now we have the actual and the expected. And the last thing we do is we need to fill out the table with the individual values that contribute to the chi-squared test statistic. So we go into the first cell, north and beef, equals, open parentheses. We navigate to the actual of north beef, subtract the expected north beef, square it, divide by the expected, and that is 0.66, and we can copy that to the right, and we can copy the formula down. Control D. Maybe let's remove some of those decimals. Okay, so now we can calculate our chi test stat, which is the sum of all the values in the last column. So we'll just highlight the sum of the 5 columns and 4 rows, and we get a chi-squared test stat of 25.33, and I'll just round that to 1 digit here. So I put a round around that sum, and I say round to 1 digit. It'll be good enough. So it's 25.3. So what is our chi critical, where we have 5% to the right? So the chi critical is equal to, so now we use again the formula chi squared, and if we want the critical, it is related to the inverse, so we use chi squared dot inverse dot RT, and 0.05. Okay, how many degrees of freedom do we have? Again, the formula is column minus 1, so we have 1, 2, 3, 4, 5 columns, minus 1, that's 4. How many rows do we have? North, east, south, west, that's 3. So 3 minus 1, that's 2. So how many degrees of freedom do we have? 4 times 3. North, east, south, west, that's 4, minus 1, that's 3. So 4 times 3, that's 12. So 4 times 3. Or we just could write 12. Okay, so now we see that our critical test statistic is at 21, but I also round that to 1 digit. So round 1. So that's 21. Okay. So, and again, we have degrees of freedom, 12. And let me just copy those 3 values quickly. And what I want to do is I want to draw now the okay, so there's a formula. We just click on values. Okay. And now I want to draw the corresponding chi-squared distribution. So our test statistic is at 25.3, and we already know that our test statistic is beyond our critical value of 21, so we definitely reject the null. But what does it look like? So we have our chi value, and now I create again a column with and that I fill with a step value of 0.1, and I think if I do it till 30, that should be good enough. Okay, So now the probability density function, that is equal chi-squared distribution, okay, x. For 0 we will get an error for 0, but it's fine, we still can copy down the formula. Degrees of freedom is 12. So I need to fix that with dollar signs. And I don't want it cumulatively because I want the actual curve and not the area underneath it. Okay, actually that works for 0 here. And so now let's see what this looks like. Insert recommended chart. Okay, so that is what our function looks like. It looks correct. And the next thing we do is we want to add our test statistic. So chi test and our chi critical. And so what I want is I want there to be a vertical bar. The way to do it is to say equals if the chi value in column A is equal to our test statistic of 25.3, but now I need to put dollar signs around it. Then make a vertical bar, which is the maximum value of all the probabilities that we have. So, and then I anchor that range 2 because that must not be shifted down as I copy down the formula. And otherwise enter number n a, close parentheses. Okay, so now at 25.3 we should see a value. Let's quickly see if we go to 25. 1, 2, 3, and we see here 0.087. So that is the peak of our distribution. Now we do the same for the critical value. If our chi statistic is equal to the critical value of 21, again we must put dollar signs around the cell where we have the critical value, in my case G2. Then again use the maximum probability, and we have to anchor that array again, and otherwise it is number n a. Okay. And I also want to show the area where we have the 5%, which is the chi critical. I call that the rejection zone. Rejection zone. I just want to have the area. Well, and the area is if so now we say if our chi is greater or equal to our critical value of G2, which I put in dollar signs again to fix it, then pick up the probability, otherwise enter number n a, and that will become an area. So the rejection zone will become an area, and so now we see that at the end, at values of greater than 21, I believe, we can display values. Okay, so now we should have a nice graph that displays our problem. So let's highlight all those columns, and then we go to Insert, Recommended Chart, All Charts, and we just can go to Combo. And now we say we want the chi. Actually, we don't want that. Let's first go to a line chart. Yeah, let's go for a line chart. Yeah, that's good enough because it has already, it starts at 0, and you can already see that light blue, that's the rejection zone, but we can see the chi-test statistic and the critical value. So this is what we need to change into a combo chart. So now we say the probability, that's supposed to be a line, but the chi-test statistic, that's a column, and the critical value is also supposed to be a column, and the rejection zone is supposed to be an area. Okay, so now that looks relatively nice, and that is exactly the problem that we have. So we can see that, let's make that a little bit bigger here. We can see it, it's good enough. So we can see that our test statistic of 25.3, so that light orange line, now let's make it bigger here. So let's format that series. Maybe let's remove the gap width and see if that makes it bigger. A little bit. Let's remove the gap width. Okay, that didn't do much, but anyhow, I think we can see it. So here, the first bar defines the rejection zone, and this falls into our test statistic of 25.3 falls into the rejection zone. Well, but still, we could have made a type 1 error, and the remaining type 1 error is now this area here to the right of the 25.3. So that's the p-value, and that is the value that we are given by Excel when we just use the Excel command. So let's calculate next the p-value. So that's the probability that we make a type 1 error, and that is given by the formula equals chi squared. Okay, so now we want distribution right tail. We want everything to the right of our test statistic of 25.3 when we have 12 degrees of freedom. And of course, that number has to be less than 5%. And it is 1.3%. Okay, so let's copy this again quickly, and let's go back to our problem set. And let's paste here again our results. And we should have now a pretty good understanding of what happens. And now if we go to Excel, we'll just tell Excel, you know what, Excel, can you do a chi-square test for us? Then we click on chi-square test, and then it wants the actual range. So we highlight those 5 columns times the 4 rows from the actual observations, comma, then the expected range, 5 columns over the 4 rows, close parentheses, and then we should get the 0.013. Again, Excel doesn't tell you that this 0.013 comes from a chi-test statistic of 25.3, but if you want to do that, we can use again chi squared, and then we use the inverse probability of 0.13, degrees of freedom 12, and then we get the 25.3. Okay, so that's pretty much it in the chi-square test. So in this case, the answer is we reject H0 because our p-value of 0.013 is less than the alpha of 0.05, or because our test stat of 25.3 is greater than the critical stat of 21, critical stat of 21. So those are the two ways why we reject. Okay, so that's pretty much everything I know about chi-square test, and I hope that those exercises helped in understanding. It shouldn't be too difficult. But anyhow, so that concludes the lecture on chi-squared. All right, so thanks a lot for watching.